All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Woo-woo. Warm-up 45 is on the screen. I'm going to give you some time for that one. It's almost spot on, exactly the same as the one we did yesterday, just to make sure you get the extra practice, see how you do. All right, copy and go. All right, number one. It says, write a compound inequality shown by the graph. What kind of compound? Brandon Felix. Get us started, please. What'd you write? Oh, it's frozen. Let it go. Let it go. 5 is less than or equal to x. Hands, have you got that? That is correct. 1, 2, 3, 4, 5. This is an OR, and if you write it in solution set, there you go. All right. So far, so good. Next, number 2. What was the LCD that we multiplied the entire equation by? Tell your neighbor before Brandon passes it to someone. What was the LCD? LCD. LCD. All right, Brandon, pass someone. Martin, LCD. It's right there. Well, let me walk you through this. Between these two, what would be a common denominator? 4x. Okay, so we got 4x. Since 4x is totally different from a binomial, then we just multiply those, and that's going to be my LCD. Hands, have you got that? Yeah? All right. So we multiply that times the entire equation, so we write the fraction again exactly the same, and then since we distribute the LCD to the first numerator, then that means we write it times 4x times x plus 3, plus, again, our fraction. And then we distribute the LCD to the second numerator, times 4x times x plus 3, equals my third fraction, 5 over 4x. Distribute the LCD times 4x times x plus 3. So far so good, yes? All right. So, giant ones, you guys see them? Yes, Mr. Q. All right, good. So we got x plus 3 and x plus 3. So that leaves us with 8x. Yeah, 2 times 4x. Plus, you guys see the giant 1 here? Yeah? The x, so that leaves us 1 times 4. Let's distribute, might as well. 4 times x is 4x, and 4 times 3 is 12. So far so good, yes? Another giant 1 is the 4x and the 4x. Let's distribute this, so that is 5x plus 15. Hands we got up to right there so far. Yeah, some of us? All right. Man, that chocolate's kicking in. Let's go. Combine like terms. This is 12x plus 12 equals 5x plus 15. All right. What do I do from there, Martin? You said subtract the smallest variable, which is 5x from each side. Now, I could have used the 12, but then I'm going to end up working with negatives all the way to the end. And I'd rather not work with negatives. I'm always positive. Let's go. 7x plus 12 equals 15. And the rest is history, yeah? Minus 12 minus 12. 7x equals 3. Divide by 7. X equals 3 over 7. Hands, have you got that by yourself? Okay. Not bad. Not bad at all. So, let's go to number 3. Evaluate the function. Check with the neighbor, see what they got for f of negative 2, f of negative 1, f of 0, f of 1, f of 2 before Martin passes it to someone. Could it had an on? All right, Martin, pass it to someone so they can get us started. Anthony, E, f of negative 2. So if we substitute negative 2 here, what did we get? Let's go. Hands if you got that. That is correct. And you're not on your Chromebooks or anything like that, right? Okay, good. F of negative 1. Pass it to someone, Anthony. Martin. Seven. Negative 7. Hands if you got that. That is correct. F of 0. Pass someone, Martin. Danny. Negative 4. Let me change this negative over here of the 7 right there. Okay. Negative 10, negative 7, negative 4. And f of 1. Pass someone. Danny. Who? Martin. Negative 1. All right. And what is f of 2? Martin. Two. Hands if you got that. That is correct. So, to graph, I'm going to write my slope-intercept form under this. And once again, remind your neighbor what the plus b stands for. What does the plus b stand for? And what does the m stand for? Plus b. Martin. Yeah, he said the y-intercept. The y-intercept. The point on the y-axis. So therefore, let me get my axes going. Let's go. Whoa. Sorry, hold on, let me change colors. Bam, technology, let's go. Technology. I like that. My goodness. All right, so we said that the plus b is my y-intercept. That means the point that we start with on the y-axis. This is the x-axis, this is the y-axis. So what is that point according to this function, everyone? Negative 4. So we go 1, 2, 3, 4. You plot your point. That's where we start. Next, we need a slope so we can start plotting points. Tell your neighbor the slope according to that function. What is my slope? M equals to what? About Martin? 3. In fraction form is 3 over 1. So the 3 is a positive, so we're going up. The 1 is on the denominator. We're always going to the right. So 3 up, 1 to the right. So starting at the y-intercept, we go 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. And that's how you graph your line. Let's go. And this is not too easy. It's tweezy. How about that? Tweezy? Good? Anyways, get your stuff. Get out the way, please. Oh, yes. Tell your neighbors bye. Aw. Let me stop the video here. so go ahead and copy the agenda for today. Warm-up number 45, Intro to Functions. Tonight we will have home play, which is play sheet Q, different notations, all only. Copy that. All right, once again, your warm-up 45 we finished. Intro to Functions, we're still in the middle of that. And your home play for tonight is play sheet Q. It's going to be in the Nearpod presentation, so make sure you copy the code. Here's the code: 9ZGXR. 9ZGXR. Also, if you fall behind on the sesh, make sure you log into that and copy whatever you missed. Okay. All right. So, last night, like I said, I gave you guys the afternoon off. Hopefully you guys made the most out of it. Probably cooked some dinner or something for your peeps at home. Good. So home play, play sheet Q, and I'll show you that in a little bit. All right, so let's go back to the packet that we started yesterday. For those of you that don't have a packet, they're over there on top of the cooler. And our objective for today, I can identify functions. I can identify functions. All right. So, what time are you guys leaving, Clarissa? 45. Okay. Oh, we have plenty of time. Let's go. All right. So, yesterday we started with functions. However, I introduced vocabulary such as ordered pairs. We went to relations, domain, and range. Yes? Does that sound familiar? Yes? From there, we went to this, and we represented relations, which is a group of points or ordered pairs, 3 different ways: using a table, using a mapping diagram, and using the graph. And it looks something like this. Yes? And you have those notes. All right. From there, we filled out our Freyer model, and we said that functions are a relation that has what? Exactly one output value for each input value. And we saw that here, and I gave you guys the example of going to the vending machine. You guys remember that? Yeah? All right, so remind your neighbor why this set of points or order pairs are a function and why these are not. Remind your neighbor, please. Why are these a function and why are these not? All right, looks like Martin, why are these a function? Why are these not? Oh, because the last one is the same as the first one. So, whenever you see an X value repeat, the Y value that we started with should be the same one. So over here, the X value repeated, -2, and it's the same one. Therefore, why is this one not a function? Martin? I'm sorry? Yeah, the last point is not the same as the first one. This one was -2, 3. This one should have been a 3, but it's a what? 7. Man, Martin's on the ball today. So, we talked about notation. We started with interval notation using brackets and parentheses. And we got started with our table. Is that correct? All right, turn to that table, please. It should be underneath your Freyer model. And just for recap, here it goes. You should have the first 3 already completed. So let me go over the second one once more. We start with a dividing point, which is 4. Everything shaded to the left is X. And then we ask the question, what are these numbers compared to 4? They are what? Less than. Since it's a solid point, we put an equal sign. What kind of notation is this? Oh, Mr. Q, this is an inequality. Bah! Therefore, to make it into set notation, we just write solution set of x such that, and then our inequality, x less than or equal to 4. So far, so good, yes? Next, interval notation. I look at my graph, look up, please. I'm doing this recap, especially for some of you that weren't here. I look at the graph, I'm going to go to the farthest left first. If I go to the left, it doesn't stop because it has an arrow. That means it keeps going to what? Negative infinity. The right side of the graph, it stops at what? 4. So we write comma 4. So obviously the 4 is included because it's a solid point, so I'm going to use a bracket. Infinity, we never catch up to infinity, so I'm going to do a parenthesis. And what does this mean? That all real numbers less than or equal to 4. And since it has an infinite or infinity symbol, this is an infinite interval. So far, so good? All right. Giving you a heads up. Warning number 1, some of you are going to mess it up for everybody else, and I'm going to have to reassign seats. Bah! My goodness. The third one, dividing point is -2, and this one is 5. And since it's shaded in between, that is what? X. Is that correct? Yes, Mr. Q. And we always said arrows to the left. Is this a solid point? No, it's an open point, so I don't put an equal sign there. So what kind of notation is this? Inequality. So solution set of x such that -2 less than x less than 5. So far so good? Yes? All right, farthest point on the left is what? -2, comma. Farthest point on the right is 5. Are they included? No, they're open, so it's parentheses and parentheses. If I recall correctly, it was Brandon Felix that told us, well, Mr. Q, it's all real numbers between -2 and 5. Is that correct? And we said this was a what? Finite interval. And that takes us to the last one. So I walked you through this one. I want you to do the last one by yourself. Do the last one by yourself, please. Do that right now. I'll give you some time. All right, check with the neighbor, see what they wrote. Look at their inequality, their set notation, their interval notation, what it means in words, and what kind of interval. All right? So, oh my goodness, bah. All right. With that said, get us started with the inequality. Who shall we pick? Martin. What was our inequality? -5. So what goes in between here? Less than for both, okay. Which one? The left one? Hands if you got that. That is correct, because this one is an open point, that one right there. So set notation should be solution set of x such that -5 less than or equal to x less than -1. Now, I don't know if you guys noticed. Here, let me give you some insight to my strategy. Did I give you practice with inequalities at the beginning of the school year? Did we bring them back on the warm-ups? And of course, you've been practicing your warm-ups, so this should be something so smooth as we get to the session, yes? So, if you see, everything we do in class, everything comes together. Anyway. Next notation, interval, what you write. Martin. -5 and -1. Parentheses on which one? On both? On the left? That one? On the right, okay, my bad. All right. So that means the one on the left is a bracket. Hands if you got bracket and parentheses. Let's elaborate with Martin as to why this is a bracket, because this is a solid point. That's why it's a bracket. This one is an open point. That's why it's what? Parentheses. So what does it mean in words? Martin. All real numbers between -5 and -1. All right, let's see if we understand what that means. All real numbers between -5 and -1. All right, tell your neighbor a real number between -5 and -1. You're welcome. All right, number, Rebecca. -3, whoa. Okay. What other number, Courtney Jean? Wow. -3, -2, okay. What other number that you don't see on the screen? Tell your neighbor, please. Vianney. -4.5. Bam, let's go. How about -4.999999923? That's what it means, all real numbers, including all the decimals in between all those numbers, all right? And do you see any infinity signs here? No, that means this is what? Finite, all right? So, this is a good activity, I like this. So, you should have a blank sheet before, there you go, somewhere in that packet. Copy these. So make a table like this, 1, 2, 3, 4, 5 columns, and then copy these graphs, and I want you to write me the set notation, interval notation, description, and interval type, as well as the inequality. Work with your neighbor, since now you got into the talkative mode. Go. Me? Let's go. All right, they chose me, so I'm going to start with the dividing point. There's 2 of them, so I'm going to go with this one first. So I'm at 0, 1, 2, 3, 4, so that's -4. Yes? And then we got to the right of 0, 1, 2, that's +2. And since it's shaded between the 2 points, I'm going to write X. Arrows to the left. And let's look at the solid points. Is this one a solid point right here? No, that's why it stays like that. Is this one a solid point? Yes, so I put an equal sign. So that's my inequality notation. Hands, have you got that by yourself? Okay, some of us. All right, set notation. Mr. Q, all right. Solution set of x such that -4 less than x less than or equal to 2. Interval notation. Share with your neighbor your interval notation before I pass it to someone. All right. Interval notation. How about someone new? How about Kimberly? Interval notation. What do I write? -4, comma, 2, a parentheses next to 4, -4, bracket on 2. Hands, have you got that? That is correct. Woo. What does it mean in words? Pass someone, Kimberly. Anthony D, go. All real numbers between -4 and 2. And what kind of interval is this, Anthony? Yes, finite. Hands, have you got that? All right. Show your neighbor the second one, the inequality for the second one. Inequality for the second one. All right, inequality. Pass it to someone, Anthony. Maya, A. Where do I start? Let me zoom in. Hold on. Five is less than x. Hands, have you got that? Yeah, the dividing point is 5. 1, 2, 3, 4, 5. And then all these are x. And what is 5 compared to all these numbers? It's less. All right? Set notation, Mr. Q, yes, solution set of x such that 5 is less than x. Now you could have flipped this the other direction, like x is greater than 5, and wrote it like that as well. That's fine. All right. Interval notation. Tell your neighbor the interval notation before Maya passes it to someone. Interval notation. All right, Maya, pass someone. Courtney Jean, what'd you write? 5 and positive infinity. Parentheses both. Hands, if you got that. That is correct. Let's go. And what does this mean? Pass it to Martin. All real numbers look at the graph. Here's 5, and all these are real numbers. Very good. You said greater than 5. Hands, have you got that? Now, do you see an infinity? Yes, so this is an infinite interval. All right? So far, so good? Show your neighbor the last one, the whole thing. I'm going to have somebody to give us the whole thing for this next one. Somebody. Oh. got it? So I need the whole thing, and I think Brandon's going to help us with this one. The whole thing. Oh, okay. All right. All right. Go ahead, Brandon Felix. Go. -1 is less than x. Let me just double check that. Here's -1. Over here is x. And less than or x is greater than -1. Hands if you got something like that. All right. I'm going to go with this one. So set notation. Continue, Brandon. Solution set of x such that yeah. This needs to be switched like that, and this one the other way. Yeah, I did that to see if you guys were paying attention. Oh yeah, you did. Thank you. All right. So -1 is, you said, greater than x? All right. So interval notation. What'd you write? No. Okay. Okay, what kind? Negative, comma. That is correct. And in words, all real numbers less than -1. And this is an infinite. Right? Am I right? Am I right? All right, hands, have you got something like that? All right, so now let me show you. Look up, please. I'm going to show you, because some of you are like, that's a lot of writing for the explanation. So let me replace some of those words with a symbol. Look up to the screen. Anytime you want to say all real numbers, all real numbers, all real numbers, just use the symbol. Pay attention to this part. 2 bars down and make an R. That's the symbol for all real numbers. And you get it, right? It shows kind of like a hashtag in between the R, like real numbers. Let's go, right? Like a hashtag, yeah, like numbers. All right, so from 1 to 5, how comfortable are you with this part so far? We got this, right? All right, so add one more row, and let's see how well we got this. All right. This time, I'm not going to give you a graph. I'm going to give you the interval notation. All right. So I started with the interval notation. You need to fill in the rest. So where do I go from here, Mr. Q? I want you to go straight to the graph, and then that'll trickle down and fill in the rest. See if you can sketch me the graph for this interval notation. I'll give you some time. Go. All right, check with the neighbor, see what they got. Then I'm going to call on someone to get me started with the graph. And I'm going to set up my number line with 0 right there. All right. All right, looks like Danelli's going to get us started. Danelli, where do I start on my number line? What, on 2? Solid or open? So she said open point on 2. Hands if you got that. That is correct. And then? Solid on negative 7. 1, 2, 3, 4, 5, 6, 7. And it's a solid. And then shaded inside or on the opposite ends? Inside, yes. That is correct. Hands, if you got something like that? All right. I need an inequality for this. Pass it to someone, Danelli. Martin, all right. Negative 7. Less than. Equal to. Less than 2. Hands, have you got that? That is correct. Set notation, solution set of x such that negative 7 less than or equal to x less than 2 without the equal on that. All right. What does it mean? Martin. All real numbers, so I'm just going to write the symbol between negative 7 and 2, and this is a finite. Finished, all right. Your home quiz is exactly like this, guys. Some of them, they're going to start with the interval, and they're going to ask you to get the graph and other things. Make sure you have that code from Nearpod. Have a good one, guys, and I'll see you guys tomorrow. Bye.